All right, so you're given the sine of theta, you're trying to find the tangent of theta. You need an identity. You need an identity that uses sine and tangent. Doesn't exist, right? Well, not on the surface. You're not going to look in here and find something that says sine and tangent. You kind of have to look under the surface a little bit. Actually, this one you have to dig maybe 2 layers down. Okay, because basically sine, and this is part of why I did this problem, that we can try to understand that if somebody tells you sine equals 40 over 41, even if you're a little bit like, what is that? It's a trig value. Okay, a trig value is a number on the unit circle. But it also means that you could, with minimal effort, deduce the cosecant. Okay, now the argument here is, or the thinking here is that means that the cosecant would be the reciprocal. So it's almost like just as good. If somebody says sine is 40 over 41, that means that cosecant is 41 over 40. Okay, you can like quickly make that, I don't even want to say assumption, you can make that statement. Is there a cosecant tangent identity? If you look in your book, there is not. So you have to look under the surface a little bit more, which means that if you're trying to find tangent, that's honestly just as good as trying to find cotangent. Okay, now we sort of hit the jackpot. We have an identity that uses cosecant and cotangent. Now you got to kind of keep in mind here that that's good. Like we're going to be able to do something. It looks like it says that 1 plus cotangent squared equals cosecant squared. So again, that's good. We're going to be able to use that. We're going to be able to select that. But keep in mind that even though I'm going to be finding cotangent, I still got to go back and find tangent. So we kind of have like an extra step at the end of this problem. Are you tracking? We're going to find cotangent, but we have an extra step at the end. We'll have to go back and find tangent. 41 over 40. Plug it on in. Plug it in for cosecant. Okay, even if you didn't get this last night, it's still a good review problem right now because whenever you plug it in, it has to be squared. Okay, that means 41 over 40 is going to be squared. Going to get some big numbers out of that. It's all right. Just get those big numbers. What's 41 squared? Okay, good. 1681. 40 squared is 1600. It's right. Okay, even though the numbers are big, you're going to subtract 1 from both sides. Now, when subtracting 1 from both sides, that's the same as subtracting 1600 over 1600. You're going to want to think of it that way because you need a common denominator. Okay, now I didn't say you can't use your calculator. I'm just saying that you want to see these numbers. I'm talking about 1681 minus 1600. You want to see that number. You want to see this common denominator number. Don't get the decimal. Even though the numbers are big, they kind of go back to sort of ground level here. They become more manageable. You take the square root of both sides, you get 9 over 40. Now that's equal to cotangent. I'll just write that right here. That's equal to cotangent. So we're only one reciprocal from tangent. And I'm basically saying that you don't need to plug into a formula. You don't need to show any work, really. I'm showing you that it's the reciprocal. It's the reciprocal of 9 over 40. That's 40 over 9. And that was what we originally were trying to find. So we're good. I didn't do one like that yesterday where you had to dig sort of down 2 levels. You had to think of 2 reciprocals. But you can. It's allowed. Okay, now this chapter, I don't want to say we're going to take it slow, but we're going to just take it carefully. We're going to try to sort of one by one understand what's going on right now.